Hello, ready for the next part? In this video, I'm going to combine lab number 5, 6, and 7. So the next three labs, because all those three labs are on the data visualization using the base function in R, as well as ggplot. So that's the ggplot, introduction to ggplot, uh, and some of the examples of data visualization using the ggplot. There will be lab number 6 and 7. So I'm going to combine all those labs in this video. So I hope you have reviewed the lab number 3 and 4 before you start this video, because understanding the basics is very important. So the first things first, I'm going to share my screen. And again, I'll turn I think probably I'll turn the video off, because I noticed that in the lab 1 and 2, the video cuts off the screen in the global environment on the top right corner in the R Studio. So maybe I'll just turn off the screen just like the lab 3 and 4, so that you can see the entire screen in our R Studio. Okay. And I'm sure you're gonna miss my lovely face, but I'll turn my video on again at the end of the lecture. So that's taken care of. I'll open the R Studio first. Just working on it. Okay, so I think that this should work. Again, this is the global environment. This is the help packages, plots, files, console, and editor window. I'm sure you're all very familiar with that. Now, just a quick shortcut. Control Shift, if you are stuck it somewhere, if the code is if you process something and the code is not working, something happened, and if you just want to completely clear the global environment, you can do the Control Shift F10 and restart the R session without closing the whole R session. I believe that there should be Command Shift and F10 for Mac users. Anyway, let's just under the packages, let's load the data set first. We are going to use the data set, as I said, like the R has inbuilt data sets that we could use. There are tons of the data sets, for instances. So we are going to use the data sets diamonds from the library package ggplot2, right? So now I know, for instances, there are two ways you can work with the ggplot2. Either you can just install the ggplot2. I'm sure all of you should have installed the ggplot2. If not, then you need to do install.packages in bracket inverted comma or quotations ggplot2, or you can install the packages here from install packages, right? ggplot2. It will appear, and you just install that. I'm not going to do that because I think I already have ggplot2 installed. As you can see, it's installed, but having that installed does not necessarily mean it's ready to go. You have to call that you have to load the library package to use that. So this is a code that you can use. And I'll also show you, for instance, is you can install the tidyverse. Again, I already have the tidyverse installed on my machine, but if not, you can install tidyverse. If you are interested, I know there are some students who would be interested in learning the tidyverse. So you can install the packages tidyverse install. It will install all the dependency. I already have installed. So I can either load the ggplot2, but ggplot2 is a part of the tidyverse package as well. So you can just get started with the just tidyverse as well. So let's try that. So if you look here, for instance, currently my ggplot2 package is not loaded, ready to use, but let's just say if I just load the tidyverse, so let's say library in bracket tidyverse, it does say it already attached the packages ggplot2 along with the other packages that are part of the tidyverse, and there was a conflict in the versions of the dplyr R function, so it will just detach that if there is a conflict. So here, for instance, as you see now ggplot2 in here, it should already be loaded. right? So you can work either way. It's just that you learn individual specific packages in ggplot, or you learn tidyverse. It's the same thing. Of course, the tidyverse involves some more functions, but let's just get started slowly. So now if you, let's just say, go to data, and I showed that in the instruction of the assignments. Now you have access to all those data sets in the packages that are loaded in your in your RStudio. For instance, as you can see, these are all the data sets that are ready to go. These are the packages, as you can see, from ggplot2. These are the tidyr packages. These are the dplyr, the package data sets from the dplyr package, and these are the package that from string r. So I'm going to use the diamonds package, but I already have, I just wanted to show that, but I already have the code ready to go. So I'll just run the code. As you can see now, it appears as once you run the code, it appears as the values. Uh, it's installed, it's ready to go. There are no errors, but there is no data set. But it appears as soon as you click on that, or you run the second code. So once you click on that, there you go. It's a 53,940 observations and 10 variables in it, right? You can click in here. You can check the structure of your data set here. Similarly, the better way to do, rather than just scrolling down, is run the structure here with the structure str structure code, and print the structure and understand that. However, what you need to do is that you can put the question mark and check the structures. I'll just save this in here as well. Uh, you can print that question mark, and you can put the question mark with the diamonds, so it brings you to the help menu, and it gives you again, it shows you that diamonds is a part of the ggplot2 package. It's a description of the data set. It contains the prices and the attributes of the almost 54,000 diamonds, and it's kind of a data dictionary that it gives you the format of your data set. So it has the 10 variable with 53,940 observations. As you can see, the price is in US dollars, so that should be continuous. What you need to do is that make sure your structure of your data set reflects what your data dictionary has, right? So for instance, this cut here, it should be fair, good, very good, premium, and ideal. Means that it should be a factor or the character variable factor ideally. As you can see, it's an ordered factor variable in here, right? So you just need to make sure you understand your data dictionary before you run any analysis, and also make sure that your data dictionary, your structure of your data set is consistent with with the data dictionary there. Okay, so let's create a histogram, base histogram. This again, the histograms and the density plots are the most trickiest plots to create, because again, you have to suit the number of the beans or the intervals that you decide. The variable that will suit the histograms. Again, go back to the theory lectures. I did say that some certain types of the variables may not be appropriate for histograms or the density plots. So you need to have that understanding. But let's just take an example. Again, this is not the perfect example, but let's just go ahead and learn how to create the base histogram. So once you learn that, you will be able to apply that with any other variable that you like. So to use the base functions, like the R has inbuilt features that you can use to create the plots. So here the plots would be, here you can call that function is called the hist function. Again, so for instance, is just going back that for you can also search, like just going back to the checking the, if you need any help, let's just say diamonds structure data set, you can use this code question mark and diamonds, or you can search here diamonds as well, and it will bring you to the same page. We're already there, but let's just go to the home. That's your home button, and if you search that, it will take you there as well. So similarly, let's just say I want to learn more about the hist function there. So I'll just search hist. search there, it will take me to the histogram. That is a base function. And it here when you search that, it gives you all the possible argument that goes with this function, an explanation of those argument, what does it mean, and when you should use it, and how you should specify those arguments, with some examples at the end. Of course, my lab videos will not obviously cover each and every argument with this function, but we will cover the most important ones that you may find useful. But again, there are more arguments that definitely we have covered. So it's that would be part of your self learning if you want to learn more about RStudio. Okay, so let's just go ahead and run this hist with, again, what I did here is that I'm specifying, this is always a good practice, specifying the data set, that I pull this variable, caret variable, so the carets of the diamond, from these data sets using the $sign. So I'm saying that pull this variable from this data set and create a histogram of that, right? So this is how you write it, and this is what the histogram looks like. Again, when you look at, you can click on the zoom, you can maximize the screen, particularly if your screen is smaller. This is how it looks. Okay. So now let's give the main title of the histogram with the main argument. So what you need to do is that, again, either you can copy and paste, or like if you're learning, maybe just type that again and again, so that way you will be you will get a grasp on the language. But what you just need to say that, okay, I'm saying that now give the main plot the title, because here I don't like the plot of the title, so you can use the main argument here. Again, what we use here, it's called the function. The argument that we add, the thing that we add after the comma, that will call the argument. I'll call them as an argument, right? So you can use that as a main argument, and under the quotes, I'll say I want to label that the plot as a caret histogram. You run that. Again, it changes the title there, right? Now, you can also title the x-axis similarly as well. In the base function, if you want to change in the x-axis title, it's called the x-lab. The same thing, you just add an argument with the x-lab is equal to caret, because that's what the carets are. Here is the frequency on the y-axis, so let's just change the x-axis first. That's a caret. Now, you can also change the y-axis limit as well. Currently, as you can see, for instance, it's 0 to 15,000, but the bars, they extend beyond the axis, which should not be, or the ticks, that should not be the case. That should never be the case, actually, right? So you want to extend your limit, so you can specify that using the y-lim argument. And you specify that it's C for combine, you want to have the limits from 0 to 20,000, because currently it's stuck at 50,000. But again, now you go, as you can see, the y-axis limits are now 0 to 10,000, which captures all the data there. So that looks good, right? You can also, like currently, as said, I think I covered in the last lab as well, it's vertical. You can also turn that horizontal with LAS argument. You just specify LAS is equal to 1, and it turns them around. Okay, it becomes horizontal now. Okay, you can also fill some color using the color argument. So currently it's gray color. You just call color is equal to, you can add that, specify the color whatever you like. Color is equal to, in quotation, in quotes, green. As you can see, the green color. Yeah, I think you can do the hot pink. Let me try. Here we go, hot pink. I don't know why it occurred, hot pink. You can also do, let's just say, gold color. See, there are so many color options that you can choose. Navy blue. There you go. Sky blue. There you go. I didn't check if all these colors exist or not, but you can definitely play around with the colors that is appropriate for the journal, for publications, and so on. Okay, so that's this is what the color looks like. Again, you can also change the so that's how you change the color of the title, by adding the color argument, COL argument there in the histogram. You can also change the color of the axis fonts as well. like this 123 axis fonts, caret and frequency and those as well. So what you need to do is that you just need to specify that with the color.lab argument. And I did say anything that you want to change in the axis, you need to have the lab argument in the title or this one. Remember, the ticks are lim argument, lim. These ones are lab argument. Okay, so you can change that the lab color as well, and you can change uh, you can change those colors too, right? Right, there you go. So you can change the color if you want to color your x-axis as well. You can also change the x-axis ticks as well. With the same, instead of y-lim argument, you can change the x. You can similarly do the x-lim argument, like c 0 to uh, 0 to 3, for instances. Let me just copy and paste the code in below. I'll just specify it over here. For instances, x-lim is equal to c 0 to 3. For instances, I think I must have not yep, this is what's going to happen. Obviously, when you copy and paste in the middle, sometimes you miss the punctuation and stuff, which is okay, and that these things will happen. As I said, when you code, there is no one that will come without an error, so that's okay. You have an error, but you figure it out. Like when you read the error, it tells you, for instance, there is an unexpected symbol in this argument, so that means that I was missing a symbol there, and as soon as I scroll back, I identified that, as you can see in here, I missed the comma there. I missed the comma there, right? Because the two arguments need to be separated by comma. So R is super picky about that, and you need to be mindful, particularly when you edit the code in between. Sometimes you miss the brackets, you miss to close the bracket, you miss to put the punctuations and so on. That is quite common. Don't get frustrated. It happens with everyone, no matter how good a person with coding is. Okay, and this is a perfect example, right? As you can see. Now. And so see, if I'm clicking the zoom, but now it's not opening the plot because it opened the plot behind my screen, this screen. So as you can see, now I have two screens open, and here is the plot, right? So as you can see, with the x-lim argument, I can also specify the limbs of the x-axis as well, from 0 to 3. Similarly, I can also do something else as well. If I do not want the x-axis ticks at all, you can say x-axis axt is equal to, in quotation, n, means I want to say that no, I do not want to have any axis, any titles on any ticks on the x-axis. So that for instance, it removes that, as you can see. And again, while you're thinking, it went roll back to the green because it's decided to specify the color green before anyways. But now I'm saying that you can also specify, instead of x-lim argument, you can also say x is 1. 1 means a horizontal axis. Sequence, I want to have that in sequence from 0 to 5 by 0.5 margin, right? And you can run that, and as you can see, you can have the x-axis again this way as well. This x-lim argument will be the easier one. X-lim argument will be easier to deal with. But again, if you want to remove any particular axis ticks, particularly for the box plot, you may want to do that. You can use this function. Again, these arguments, like the histogram is a function, but if you build any of the plot using the base functions, this argument x-lim, y-lim, color.lab, all those arguments will be transferable. Okay. You can also change the main color of the main title using the color.main argument. Again, if you want to change the lab titles here, as you can scroll, see my cursor, that's a color.lab argument. Here, it's a col.main argument, right? So it's a col.main argument, and you specify the color. Please don't don't worry about my selection of colors. It's never been great. Okay, but this is what the how this is how you can pick the color that works best for you. You can also change the number of the bars. Like, remember, the histogram is that you put the graph in certain intervals, right? So the bar means that you decide how many intervals you want to have. uh, so you can specify that with the breaks argument, where if you specify breaks is equal to n, it will result in n plus 1 bars. So you just specify that with the breaks argument, breaks is equal to 10, it will give you 11 bars. Now, uh, it ran the code, but if you're wondering like why I don't see the 11 bars, it's because 1, 2, 3, 4, 5, 6, 7, and it still goes beyond. You don't see the bars in here because it's there are very few sample sizes. This is the skewed distribution that you see, and that's the reason why I say I think the histogram in this example it's not appropriate. Okay, and again, like you can cut off the limb at 3, not even realize that there is some data in there. So what you need to do first is that finding the maximum. What is the maximum limit for this variable? So, and you just want to make sure that you are not cutting off any data, right? So you can see the maximum is 5.01. That's the reason why RStudio has the x-axis by default until 5. Does it make sense? So always check the minimum and maximum of any variable before you plot them. So like run some descriptive so that you know you are not cutting. You are saying that okay, there is no data, but there is no data because it's the number of the frequency beyond these points, it's extremely low. That's the reason why you don't see them, right? But you can actually, so that there are actually when you specify the 10 breaks, you should have the 11 breaks in there. Okay. You can also specify the breaks at specific intervals. Like you can say, you can say breaks is equal to C for combine. I want to have breaks at this level: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 10. Uh, so this is how it looks like again, but it also stretches your x-axis as well, because I said my break should be until 10, right? I could have specified until 5 if that's what my data is until. You can specify that. Oops. I think it's not gonna. I think it's probably. There you go, because I think it was cutting the data off. It did not work. So in error in the histogram, diamond squared caret, some x not counted. See, because remember my data went until 5.01, so I was trying to cut the data off at 5, so that is the reason why it didn't work. So that's why I mean uh, I had to go until 6, right? So that makes sense. So you can specify the breaks argument. It's specific. So what I was trying to mention is that you can have the breaks argument with this, you can specify the numbers and it will automatically divide that until whatever your data has. So it's break, if you specify break 10, so it will give you 11 bars, or you can specify specific intervals as well. You can also use, not us, you can also use sequence argument in the break command as well. So you can say, I want to have 0 to 6 by zero point 0.5. You can also specify that. And again, 0 to 6 by zero point 0.5 as well. So that should work. Okay. So this is how you create some histogram. But remember, this is a frequency histogram. You look at the y-axis is frequency. You can also change that to, remember in the theory we learned about the density plot as well, or the probability histogram as well. So let's see if I want to, rather than frequency, I want to have the density. So what you need to do is that frequency, you just have to add an argument called frequency is equal to false. So once you do that, again, that creates a density plot. That creates a density plot. You can also do the same with, rather than frequency argument, you can use a probability argument, because it's a probability, right? Density plot, density graph. So you can specify probability is equal to true. Either you write T in caps, that should run the plot. If you just write true like this, it will not run. It will give you an error. It has to be all in the uppercase, and R is super picky about that. So either you write complete true in uppercase or you write just T. Uh, it's either is fine, but you cannot write like this. And again, when you write it, it gives you an option. Okay. And again, if it comes like if it shows you something like that, and if you click an F1, it prints it gets you to the help menu, so that you better understand that argument. Okay. um, just wanted to show you that. So I'm just gonna save some time. Just I just like small, save as much time as possible. Um, so that's again, that does the same thing. Okay, and here as well, you can just have the F as well, and I think that should work too. For instance, there you go, right? I'll just turn this back. So, and remember that all individual argument that we use in the histogram, that you can also use in the density plot as well. I'm not going to go into the depth again, but again, you can use all those argument: xlim, ylim, xlab, las, color, col dot lab, col dot main, breaks. You can specify all those arguments in the density plot as well. You can also add a density curve as well. If you just want to have the density curve, what you can do is that just lines, you can specify the lines and density, and you can specify the variable. It's the same thing. Run the density plot for this one, this variable from these data sets, and add a density curves using the lines argument. And this is what argument looks like. But as you can see, the curves, obviously the density curve goes beyond that. It's remember, the y-axis is not completely, so we have to let's just extend the y-lim to 2.0 argument, and again it does stretch that y-axis. And now let's recreate the line using the lines argument again, but specify the color of the line as well with purple color and width 5. So that gives you width. It just gives you how thick you want to have your line as well. So this is very, as you can see, it's a very nice line. However, remember, as I said, like, you can do that in the software, but this does not make sense. Like, remember, the density plot, the total area that below the curve should be 1.0. Here, that is not the case. The reason, because it is not an appropriate to learn. And the lines, again, the line that it runs to to create this density plot, it's not the method. Like, you can create that with different statistical methods. You can create a line, but that is not an appropriate one for this variable. Okay, so that is the case of what you see in here. But when we'll go to the ggplot, I'll show you there are two different ways. At least you can create a line in using the RStudio, and you can also create the linear model as well. But we'll talk about that in the next lab. But again, I just want to show you that particularly if your variable has fewer intervals and it's not too big, the density plots would actually work better. Okay, so but again, refer back to the theory for histogram and density plots. But so that concludes the creating the histograms and the density plots using the base function. Now let's create the box plots. Box plots, you can create the box plots using the same thing. So let's just see, again, you may not, let's look at load the different data set. Using the PBC data set, we'll use them from survival package. You may not have that installed, so you may want to install the package first. I already have that installed, so I'll just go ahead and use that. Okay. Okay. And again, I think I didn't even notice that when we created this plot, we had an error because of the number of the weights. As you can see, it's not a graphical parameter. Again, that's the reason why I said the density plot on this particular variable didn't fit very well, and you may have to specify the weight that is appropriate for the plot. Okay, so that's an error, but it's not that it did run it does run the graph. But again, that does not mean that it is meaningful. Okay, you have to specify, you have to look at if your variable is appropriate for the type of the analysis that you're running. Anyways, let's clear the environment. Let's clear this global environment. If you want to, that's okay. If you don't want to, that's fine as well. It doesn't matter. your R should be able to handle multiple data sets in the global environment. It should not be an issue at all. Uh, let's load the survival package, and then you run the data PBC from the survival package. As you can see, when you load the PBC, it loads the two data sets, PBC and PBC sequence. That's a follow-up data PBC sequence that you see, which we will not be using. You can learn what those softwares are. You can So we will be primarily using the PBC data. You can check the structure of the PBC data using the structure command, and you can also make sure that it is consistent with the data dictionary that is given in here. Okay, if not, then you may have to make some changes in your data set. Now let's go to the box plot. How to create a box plot? Again, just you can just search help in bracket box plot. That's one way to access the help menu, or you can also put the question mark and the box plot as well. It takes you to the same thing. Okay, and again, these are all the arguments. These are all the arguments that goes with the box plot, and again, it explains what those arguments are. Okay, so spend some time to understand and to learn the different argument that goes with the box plot. But again, I don't think you should. I think that creating a box plot using ggplot package, it's far more powerful. But I think you should just know a little bit basic as well. Okay. So you can use the most of the arguments that we discuss in the histograms, like the LAS, color, xlim, and all those arguments. You can use that in box plots as well. Okay, so let's just create a box plot of the cholesterol variable. So which is an integer, as you can see. I'll just create a box plot I'll specify the data set, $sign. I specify the variable name, and I'll just say color is equal to gold. I want to have that in gold color. You specify that. That creates a beautiful box plot right here. Okay. Now, as you can see, there are so many outliers in the data. This is where, again, the interpretation of that, I'll not go into interpretation, but that's what you need to connect the theory with the lab, that you should know what this line represents, what this lower and the upper, the box, the lines represent, what are these whiskers, what does it represent, and what does this mean in terms of the outliers. Okay, so that's something you need to connect with the theory. You can also create, that's a beautiful thing about RStudio, is that you can also change the color of the box with a different color as well. So currently it's inside it's a gold, but outside I want to have the blue color, the border. So you can do that with the border argument is equal to blue. As you can see, the borders have turned blue, right? And you can also turn off the outliers. Currently, as you can see, there are outliers in the data, but I can turn that off with the outliers is equal to false argument. Outline is equal to false argument. Outline is equal to false argument. You do that, it removes outliers, it expands your box plot. Now the question is, should you remove the outliers from the box plot? Absolutely no. Okay, unless it's a one extreme observation, and if you put in a footnote, that is a different story. But your readers need to know if there are outliers in the data, right? It gives you the more full picture about your outliers. But in certain scenarios, it would make sense to remove certain percentage, but that is okay. But you have to disclose that. Okay, particularly, but the positive aspect of turning off the outliers is that, as you can see, it expanded your outlier for better understanding with the y-axis or the y-dix. Okay, so I'm just showing you that that is an option in the RStudio as well. Another important thing is that you can group them by different another variable, another factor variable. So if let's just say if the sex is as you can see in the data dictionary, it's a factor variable. If your variable is factor rather than character, R can do a very powerful thing in data visualization, particularly with ggplot2 package. So there are advantages of having factor variable over character variable, particularly when you are using for data analysis or data visualization. So here, for instance, is if you just want to have by sex, if you want to stratify the cholesterol level by, let's just say, if I want to look at the cholesterol levels by gender or sex, what I just need to do is that I just need to specify that this is the uh, uh, cholesterol variable, and I want to specify by sex. So before the tilde sign, it should be your y-axis, y variable. Here it should be your x variable. after the tilde. Whenever you use the tilde with regression, in the regression models as well, we'll specify y and x just like this. Color argument, everything else stays the same. So now you have the two different uh, uh, box plots that are stratified by sex. So these are the males, these are the females, and then you can compare. As you can see, there are more outliers in the females versus the males, right? So you can do the interpretation. You can compare the median. You can compare the distribution fairly with the in the box plot. And you can also, of course, change the titles, rotate the y-axis ticks as well with LAS argument. You can xlab, ylab to change the title of the x and y-axis, and the main argument to change to give the title to the plot. As you can see, I gave all those titles, and this is what my plot looks like. And with Wiley argument, you can specify the y-axis ticks as well. Now, and this is the reason, for instance, is now as you can see, it's M and F. It's probably because my variable is coded like that. As once you click on the data set, for instance, it opens up, and as you can see, your sex variable is F and M, so that's why it's M and F. Now the problem would be uh, it's not publishable because you want to have male and females in the data. So what you need to do is that you need to recode this variable into or label that variable into males and females. I'll have you try on your own if you see if you can do that, and then plot them and see if you can fix the x-axis ticks to males and females. Okay, if not, then we'll cover in the day when we talk about the data transformations, but we have already covered some aspects before. So try that. So this is how you create the box plots. Okay, so as a part of your learning exercise, what I want you to do is to develop a box plot of alkaline phosphatase, which is a liver enzyme that gives you an idea about from other things as well, but it primarily gives you an idea about, let's just say, how your liver and the gallbladder functions. So you can develop the box plot of alkaline phosphatase and group them by sex, and using the different arguments, make sure your plot is appropriate and complete. Okay, when I say appropriate and complete, means that give the title, give the x-axis title, give the y-axis appropriate title, and you can also use the different y-axis appropriate y-axis ticks as well, and you can stratify by them different sex. You can also actually turn the box plot around, sorry, horizontally. So currently it's vertically, but you can also flip them using the flip argument. It's given in that. I'll let you figure that out, but it is given in here. So it's in here, and you can find in the topic flip. See if you can find that somewhere here. It should be given somewhere here. It's a okay. There are some arguments. I think I don't have time to go through them right now, but that should be there should be an argument that so that way you can. It may not be the flip argument. It may be some other argument where you can flip. Yep, indicating logical, indicating that if the box plot should be horizontal, default is equal to false. But you can say, let's just say we can try horizontal is equal to true, and let's run that. There we go. Right, so you can turn the plots horizontally as well, and that's okay. I think as you can see, like for instance this with ggplot we use the flip function. That's why I think it was in my mind, but again that's okay if you don't have to remember each and every code because and that's not an exam, right? What you need to know is that the base functions and then main arguments that you commonly will use, and then you know how to access all the possible argument that goes with the health function, and just be able to figure that out on your own. Okay, so that's all part of the learning, and no matter what stage you are, we all have to keep learning. Okay, so this is there are so many other options that goes with the box plot, so make sure you try and practice them very well. So that's your lab number 5. Let's and there so there will be an exercise for that will be part of this that will go with this lab. Again, the deadline, of course, this is the last year's assignment, so but the deadline will be changed. I'll post the relevant deadline. But you need to build the histogram using the below sequential code. What I want you to do is that for every code, every instruction, write the code for that and just build them subsequently, right? So that will be the first assignment for you. This is the second exercise. Remember here, for instance, is what you need to do is that load the PBC data from the survival package. So you may want to library survival, and then you need to load that. And then you need to do the histogram first, then change the x-axis in the third bullet point. So when you write in the RStudio, just RStudio, make sure your script has the hash note. So this is number, so you can say the pound key, instruction number one. For instance, you can write like this in the console. I'm not going to write that. I'm going to write in the console here. Uh, you can write instruction number one, load PBC, and then you can write the code. And then once you're ready, uh, number two, uh, build histogram, and so on, right? So make sure you have some notes before every code, so that so that I can see if you are following the each different code or not. Okay, so that's the first exercise. It should be pretty straightforward. Make sure you follow the instructions very well. Exercise two is that create a box plot using the below sequential code. Again, I said that here it's more arbitrary, because again, when you do publications or when you create a plot for thesis, no one is going to give you the detailed instructions like this. So what you need to know is that your plot should be complete, right? So complete the graph using the different arguments. So as long as your arguments make sure the graph looks clean and attractive and is informative, that is a keyword as well, that should be appropriate. And then exercise three would be the same thing, but then I think you have to uh, stratify that by the sex variable. Okay, so make sure you complete that. This should be your take home assignment number one.